We're going to go ahead and get started with a couple of quick introductions for the team. My name is Lisa Pedersen, and I'm actually not going to talk about roles because one of the things that we've talked about is how this is really a collective design process, and it doesn't matter what your role is because everybody's involved in the design process. But joining me is David Webb, Eric Reidenauer, Emily Wright, and Jenna Burt. And now we're going to tell you the story of OSU-Cascades.
Great. So I'm going to give you a little background, starting with deep background. That Central Oregon, as most of you know, is an amazing place, very unique, very different than the Willamette Valley, both geographically and culturally in many ways. And OSU-Cascades exists to be a four-year university for Central Oregon, and it was a long time to get there. I'm going to summarize that story briefly before we get into the specific project that we want to share with you tonight. One of OSU's principles is they want to be true to their place. They want to be true to the landscape, dramatic landscape that you see in the Intermountain West, as well as the site itself, and the images you see here are representative of both. Sorry, just making sure. There we go. My clicker working there. So OSU-Cascades has been in Bend since the early 2000s. There were actually courses offered before that by both OSU and U of O. But it's been in Bend as OSU-Cascades since 2001. But that first decade or so was really just leasing a single building and having a presence on the Central Oregon Community College campus. In the early 2010s is when OSU committed to the West Bend area where the campus is now. That they bought one existing building and then started to build this campus. There we go. This is a quick overview of the land that is housing the campus, which is still growing. It's a relatively young campus in terms of its development as well. So if you think about Bend, it's in the just west of the West Mill District and west of the Deschutes River. And they started with that little area where you see a cluster of buildings in the bottom corner there. That was about a 10-acre site where the first buildings were built. And even as they were building those, they started to plan through a long-range development plan process for the rest of the lands that you see there. You'll note in this diagram that area indicated as a 56-acre site. That was a pumice mine. You can see that it's still a hole in the ground in this image. And then you can see to the north of that, to the right and above, is the old Deschutes County landfill, which was for construction demolition debris. And one of the big questions in the long-range planning is, do you commit to buying the landfill? An early decision was, yes, you needed to meet their aspirations. And this is an image from a similar angle of what the campus might look like as it builds out over time. So with that original development in the bottom corner and showing the level of construction it's going to take to house 5,000 students academically and up to 40% of them physically on campus, as well as an innovation district in that right-hand corner. The process of working on the long-range development plan, I should say that prior to joining SRG, I was at a prior firm and was part of the team that wrote the LRDP, working with a team led by Paige Sutherland Page. And so I was involved in that part of the process prior to my joining the SRG about 6-7 years ago. The two graphics here are both very telling. The one on the left is from a workshop that was all about housing and getting the housing approach right on the campus. And the one on the right was about everybody's favorite campus planning topic, getting the parking right. You can't do planning for campuses if you aren't willing to plan for parking. And that was, of course, a concern for the community. And I'll just say really briefly, it was really interesting because it was a two-edged sword. On the one hand, you didn't want people parking on the neighborhood streets. On the other hand, you really wanted to motivate people to not use cars. And so you didn't want to over-provide parking. So a lot of interesting conversations through that lens. And then there was a robust programming process, which Paige really led to get the program right, but not over-program the site. OSU-Cascades continues to want to be lean in their aspirations of how much they build to serve their students. And so here is an updated, more recently updated vision of how the campus might phase out and continue to build out over the coming decades as they approach 5,000 students. They are tracking really well. They sort of adjusted after some post-pandemic trends like every university has seen, to the point where this fall they have their largest incoming class yet, which is exciting. That was just announced in the last few weeks. You may have seen that. This is a diagram that is characterized by primary use of the different buildings. You can see the legend there, but the yellow being the housing, they really wanted to bring some of that into the heart of the campus so that the heart of the campus would have a real mixed day-night level of activity. And you may be seeing some news in the press recently about them launching their innovation district. Just in the last few days, they've started reclaiming the land from landfill that is under all those purple buildings and will be part of their innovation district, which will be launching over the next year or two. And then the last point I'll make here is that they have been very aggressive about what they characterize as their net zero triple goals: water, waste, and energy. And so they have authored, with Integral Group's lead, they've authored an energy study that led to them putting in a geo-exchange groundwater thermal system for the whole campus. And the building you're going to hear more about tonight is the first to make use of that. And they've also authored a study about what would water neutrality or net zero water look like on the campus. And they're starting to work towards implementing that. For example, introducing purple pipe and systems like that to be ready for water recycling on the campus. So this is a brief overview of how the campus looks from a drone these days. That early development is at the far left there. And you can see that the former pumice mine is less of a deep hole. It's more of a gentle bowl as a result of the remediation. And you can see some of the facilities that have started to be built since then. At that point, I'll transition it to the rest of the team.
Yeah, thanks, Eric. So with that kind of background in terms of where we were building and kind of the context of what was happening, I wanted to remind everybody, because I think many of you on this call might remember that this particular project came out as a design competition, RFP, in late 2018, and the competition spanned over the Christmas break and into 2019. And the brief that OSU came up with was really around three big topics. They wanted a project that was flexible and adaptable, that would serve as a prototype for the future. They wanted to demonstrate that net zero energy goal that Eric mentioned could happen on this building, essentially. So the building would prove as an example prototype for the campus. And they wanted to incorporate what they called a meaningful use of mass timber. But they didn't really talk in the brief about what was meaningful. So that was always a big question, I think, probably for all of us. So one of the ways that we started was thinking about how could we take this concept of prototyping and just make sure that we incorporated it into that early design thinking that we were doing in the competition. So this is actually part of that competition entry. And how could we think about the spaces that would be incorporated, and how could they change over time? And what would be the fixed elements and what would be the adaptable elements? We also wanted to take it a step further and think about programming and how the building blocks of the actual program itself could be thought of in different ways to take advantage of that net zero energy goal as well. So this is what the team is actually called the quilting diagrams, and thanks to Jenna for making these actual diagrams. But what they're trying to show is there's different ways to think about how you would program space. What are the adjacencies? Do you have them adjacent by the program within this facility? Do you have them adjacent and what makes most sense from an energy use perspective? Or do you look at it more from activities, what need daylight and what doesn't need daylight? And of course, that leads to the net zero energy approach. Eric's already spilled the beans about the geo-exchange system that Integral Group eventually led. But at the design competition, we didn't know that that was an approach. But we thought that that would be a really strong solution. And so we were even incorporating it in that. incorporating radiant slabs, looking at how we could have a carefully tuned facade, and of course, looking at the roof and what the roof would be able to do to achieve that net zero energy goal. And we'll talk more about that later in the presentation. But I'd say that the meaningful use of mass timber was probably the thing that actually in some ways changed the most from our competition entry. We came into the competition thinking a hybrid approach with a steel structure with the CLT decking was going to be the award-winning approach. Shortly after the design competition, OSU went out for a separate selection and selected Swinnerton Builders. And we learned from them that actually the most economical solution, because of the tolerances, was to do an all mass timber solution. So that checked the box for meaningful, at least for me, I think it did. One of the interesting things that as we started to learn more about Central Oregon is how do you talk about mass timber in the regions that you talk about? It varies a little bit by region, and especially at that time. So in Central Oregon, we talked about it supporting the regional economy, about the speed of construction that we were able to see. We didn't talk so much about the carbon sequestration. That wasn't something, OSU was interested, but they're like, maybe don't talk so much. Of course, we talked about improved daylighting with users and the idea of a renewable resource and that biophilic response. Those were important to the users as well.
Ray Hall was designed to serve the STEAM disciplines, which is science, technology, energy, or engineering, art, and math. The building has classrooms, maker spaces, labs, research spaces, offices, and collaborative space. And like Lisa said, we were designing for maximum flexibility, so the furniture and equipment are all movable or adjustable. A lot of the furniture is not fixed in a lot of the lab spaces, so that allows for us to move things around and think about the future of the classrooms. This pictured is the main event space, which has bench stair seating that can be set up like for graduation or TED Talk events, or like it's shown here for everyday studying and casual meeting, which is that's what it's mostly looking like without furniture. And then this is the research spaces. The research spaces are currently designed for an energy engineering lab, water and energy technology lab, and force biomechanics lab, which even after 4 years of working on this project, I will continue to say bioforce mechanics. And so you can see in this picture here that all the furniture is movable. Also, like, the walls are not structural, so you could technically tear everything out and do new stuff, but I doubt they're going to do that. And then the next slide. The OSU-Cascades also has a physical therapy program, and this classroom is being used for massage therapy space. They have a couple other classrooms similar. They also have a cadaver lab. And this was one of the most challenging spaces to design for, like what Lisa was showing with the quilting diagrams. This space was hard to design for because of the energy use. It was pretty energy intensive, and there were security concerns. And so when we were doing these diagrams, we ended up placing it on the top floor to shorten the length of the mechanical systems. And, for security, less people on the fourth floor. This is the maker space. You can see that it has the collaborative meeting rooms in the background as well. And this is right off of the lobby space, so it's really great for OSU. Whenever they have prospective students coming in, they can see what's happening right away, and I think it's good advertising for the program. As you can see, the tables are also movable like the other ones, and all the electrical is on cable trays so that you can cater the room to whatever the needs are. This is another one of the casual seating places for people to just meet outside of the offices. There are other offices, but you'll see that later when we get into interiors. I think
it's me. So one of the things that you heard Lisa talk about was the meaningful use of mass timber. So we took that initiative to heart, and one of the things we did was we were concerned with the fact that if we buried the structural columns within the wall, we wouldn't see them. We wanted to pull them inboard, and one of the conversations we had is how can we achieve a 3B building? And you can see that the exterior bearing walls in that highlighted B column needed to be 2 hours. So what we had done was we pulled those structural columns inboard of the exterior wall. They're supporting a cantilevered CLT concrete composite deck above, but the exterior walls are not load bearing. So it was able to achieve the things we hoped to do. It also gave us a nice pathway to run some of the utilities for the sensible fan coils between the exterior face of the column and the wall to run the hydronics through without having to go around the column. So it was a pretty slick way of moving just one little element to achieve what we hoped for aesthetically. And in plan here, in the right side of the screen, these are floor plan details. You can see the glulam columns on the grid points that they're pulled inboard of those the sheetrock walls that actually completely run around behind them. You get a sense for the honesty of the structure this way. You really get a feel for the path of structure, and it becomes very evident how the building is supporting itself. Also allowing, as Jenna talked about, the flexibility in the future that the interior walls are not load bearing, so they could be reconfigured for flexibility if needed. In the larger diagram, you can see that most of the building in this structure is considered a B occupancy for the educational use, although we have some fairly large assembly spaces that you saw in the big picture we'll get to here that we wanted to create A spaces. So this image, you can see those columns that are pulled inboard. They're supporting the beams clearly. It's really clear how the systems work to people who are not even engineers. So this was where we were going with keeping the wood as honest as it could be.
Meaningful use of mass timber.
Meaningful, yeah, both in structural need and for just beauty and aesthetics of the wood. This is the other end of the view that Jenna had showed from the top way up above the stairs. This space was critical to the college. They want to be able to open up the doors on your left in the nice weather. There are large gathering rooms on the right side that also get opened up too. So there was a lot of opportunity to build spaces for larger gatherings. And in order to do that, we had to understand how to protect the building from a fire rating. We actually wrote an alternate means and methods to be able to control the smoke and the ratings without completely encasing the CLT beams and columns and the underside of the deck. So we had some friends of ours that helped us write this. We presented this to the jurisdiction before we had permit submission, so that was agreed upon before we went forward. It was a pretty clean way of trying to divide the building up in use. And one of the things that I mentioned is we're cantilevering the decks because the decks are going just beyond the edge of the columns. We had to come up with a way to keep the composite function of the concrete tied to the top of the CLT so it wouldn't slip back and forth in a seismic event. So you can see these large screws that were screwed into the perimeter of the CLT with that large machine on the right. Then the concrete would be poured. It's a 4-inch concrete with conduit. Also has all of the rebar in it. So it's pretty heavy duty, but it was also a pathway for us to run utility on top of these CLT's elements.
Another important takeaway for us was leveraging the benefits of mass timber with other systems like the mechanical systems. So we ended up using a parametric tool called Design Explorer, which is shown the parametrics on the bottom of the screen. And we were able to use this to simulate what size window would allow us to reach maximum daylight with minimum glare and minimum global warming potential. So from a couple different studies, we ended up choosing a 35% glazing. And this tool also helped us decide how much shading we were going to have as well. So that the diagrams that Lisa showed before of the shading on the axon was developed through Design Explorer. The 10-foot bay size allowed us to eliminate the perimeter beam and raise the window head to the underside of the CLT decking, which helped us increase the daylighting in the space. we were able to get around 5 to 7 feet of extra light into each of the rooms, and we had such deep bay sizes, so this was really critical for the spaces to not have a bunch of extra added light. And you can see the diagram below showing our target illuminance was still great, but it was much nicer to get all that extra light in the rooms. On one of the projects I'm working on now, we did not have this, and you can really tell in the lab spaces.
So one of the interesting things that we were able to do is at the same time that we were using the Design and Explorer tool that Jenna just described, because we were using a CMGC process and we had the trade partners involved, we were also able to say what mechanical systems would work with each of these different percentage glazings. And Jenna said that we decided upon the 35% based on the daylighting of it, metrics and being able to really adequately daylight it. And then we asked ourselves the question, okay, is that going to give us enough flexibility from a mechanical perspective for those 3 systems? And if you notice, radiant panels was the one system we couldn't use. So this diagram is really showing, well, where does a radiant system, is it required because of the loads? 2 different areas where we really were significant. One is that large space that we showed earlier, where we have the potential of having up to 200 people in a TED Talk area. And the other is the cadaver lab that was mentioned. By putting the cadaver lab on the roof, we were able to incorporate a direct exhaust system. And by putting the TED Talk area on the ground floor, we incorporated radiant in the slab, and we're able to achieve that as well. It also was an important part of this was to be able to use the geo exchange system that Eric had mentioned earlier.
Yeah, and this diagram obviously is very high level, but a little more on that. The system that OSU selected is a nodal system, and by that I mean over the long term, as the campus builds out, there will be as many as 3 or 4 sets of wells, one extracting the water, one re-injecting it after it's been through heat exchangers. And each of those pairs of wells and the heat exchangers will serve a node of the campus. And so there's a temporary building called the Campus Energy Transfer Station that's a little distance away from Ed Ray Hall. That is where those pumps are sited. The long-range plan actually anticipates that in the future, that temporary building goes away and these become a ground floor or basement use of a future academic building, so they get embedded in future growth. But Ray Hall was the first building to take advantage of that heat or cooling source from the groundwater.
So as you're designing a net zero energy building, you work from both ends, right? So you say, well, if it was a typical building, what would be the energy utilization intensity? And because of the mix of program, with cadaver labs and energy in environmental studies labs, it's higher than a typical classroom at about an 80 EUI. All of the things that the team has mentioned, the great daylighting, the geo exchange, the facades designed parametrically, that got us from the 80 down to a 37.2. It'd be too big of a roof to be able to really achieve that goal of OSU's of demonstrating net zero energy on the building. So the next step we looked at were some operational strategies, which I'll talk about in a minute. And then what are some additional energy conservation measures that would get us down to an EUI of being between 26 and 28. And actually the client told me today they are operating with an EUI of 26 right now. So that was pretty interesting. So here's kind of the slide that shows the detail. And one of the great things about being able to work with the trade partners and our energy modular AEI is we were able to show the client what would be the consequences of each of these different in operational strategies. If they agreed to an unoccupied temperature setback, that would be an EUI decrease of 2.2. So it helps get to that over goal. If they wanted to expand the range, it was 1.1 and so forth. So we went through each of these different strategies and basically got client buy-off by showing them what the savings potential would possibly be if they were willing to agree to incorporate that. Then for that last little bit, we did something that I've actually never done previously in my career, which is figure out what the first cost per EUI would be for each of different strategies. We had set aside a pot of money in our overall cost estimate. And then we worked with the trade partners and our engineer to figure out how much EUI savings would be associated with each of these measures, and then developed what's a first cost per EUI. So we could go to the client and say, do you want to incorporate these or not? And the first one, this changing of the solar heat gain coefficient of the north glazing, actually was lower first cost. So it's kind of like a no-brainer. We should absolutely incorporate that. But ultimately, we incorporated all the way down through number 6. We actually did not do number 7. And then the other piece that we were looking at is using a choosing by advantages system to select the actual mechanical system. If you remember the earlier slide, we were looking at VRF, sensible fan powered boxes, and chilled beams. The y-axis is actually the score that OSU would provide. How does it do for maintenance? How does it achieve the energy goals? How does it achieve the aesthetic goals? And then the x-axis is the overall first cost. And what you can see is that the sensible fan-powered boxes almost scored as high as the chilled beams, but were significantly cheaper. And so ultimately, that's where we went. And it was a great system also in terms of being able to incorporate within the mass timber. And so here what you see is the mechanical in the corridor with the beams and going into the actual fan-powered boxes on the perimeter.
So moving into the interiors, I think we've talked a lot about kind of the technical aspects, but I think another big piece of this meaningful use of mass timber was, if we're going through all this energy to have it in the building, how do we really highlight it and create it as a focal point? And also create spaces that feel very comfortable to be in, and really connect to the surrounding environment, I think, with a really unique setting as being in this former pumice mine. We wanted to be mindful of how you create those connections and kind of biophilic feelings within the space. So throughout the building, we really looked at highlighting, the height of the wood in spaces, again, the big access to natural daylight, but also creating some elements that gave you a sense of place throughout the building, and also, overcoming some challenges of when you have a hallway full of these timber columns. It turned out that you couldn't tell where any of the doors were located, and so kind of some of those puzzles that we worked through. But again, just really highlighting that wood as the main material, and everything else really being secondary to that. Also really being mindful about where we were able to bring in exterior materials into the interior of the building, again, highlighting that wood. So that was another important aspect. But those areas are also where we're creating connections between that exterior space and the interior buildings. And one of the main areas of that is the central stair that we talked about a little bit. So this is at the end of that large flex space. Again, really wanting to connect to that exterior so you can see how the stairs are mirrored on either side. But what was really special about what happens on the interior of the building is that in addition to the CLT as mass timber in the building, the team was really interested in utilizing mass plywood as a locally sourced and kind of new mass timber product. So we really wanted to challenge ourselves to think about how we could use that mass plywood in a way that was unique to its qualities as a material, and also highlighted the aesthetics of it, having that really unique large mass ply edge. So the mass ply itself creates the structure of the central stair, and then those additional planks create the benches that you see built up. So it was a really unique structure and unique way of doing it, and allowed that plywood to be kind of its two things, where it was visual and a structural material within the space. And then also just highlighting that ply edge. I think that was something that we were very interested in, as well as bringing in some of the other materials, so the perforated metal and structural steel that are incorporated in other parts of the building. And so really bringing that into the showpiece in this flex lobby space.
Yeah, there was just some interesting things that we went through with that stair that practically we found out that you could see through these black mesh risers, for lack of a better word. You could see the sloped plywood and all the dust and every conduit that ran to these little power sources. So it was a development of an aesthetic idea that we had to work through with our trade partners. We ended up painting a flat black on the top of the sloped mass plywood panels to hide some of that stuff that really let the the edge of those mass plywood sing and really be the focus of that stair. So it was a very interesting development that we just all worked together to solve. And along the way, we found out that we had a design hope that the ceilings within the classroom spaces and any of the outboard rooms along that main double loaded corridor would be clean to express the wood, be meaningful for us. So the only elements we wanted out there between the beams were to be sprinklers if we needed them, and then the singular light fixtures. So in that vein, we had to really coordinate with the teams, the building teams, the trade partner teams, with using our BIM models and bi-weekly meetings to run through coordinating where every element went. And what you see on the top picture is conduits and junction boxes sitting in the concrete composite deck on top of the CLT, which was our pathway to run data and electrical power. This is a comparison between our BIM model on the left and how we've stuffed everything in this hallway so that we can keep those rooms clean. And then the final result on the right, we did have to work with the maintenance team at OSU-Cascades because they had to have access to a lot of those filter sets and all of the fan coils that were up there. And you can see the main wire tray, which is suspending the main light fixture as well. That was something we needed access to keep the flexibility for the rooms in the future alive. And then the last thing, I think this is my last thing, is really about these wood frame connections. The city of Bend had not built a building of this scale using mass timber as a structural member. So they were a little unsure of how this product would be used. We were able to bring Katina, our structural engineer, down, do a pre-construction meeting, pre-application meeting, to walk through with the city of Bend and their third-party reviewer in how this was going to be proposed. And I think once that was kind of walked through with them, they seemed to have the light bulb go on that this seems like it's really doable and it makes lots of sense.
So the last chapter of our story is really about the actual mass timber and the suppliers. We were able to procure our mass timber through about the 20% construction documents. So we were able to take advantage of the companies that you see here. So Zippo Laminators provided our blue lam columns and beams. Ferreris was the mass plywood for the stair that David and Emily just talked about, and Vaughan provide the CLT. We didn't really plan it. We were doing the LEED certification in terms of being able to look at how far things were, but everything was within about a 500-mile radius, which really worked out well in terms of thinking about this as a regional building. But one of the things that was a little bit of a challenge is to think about how the different vendors, because it was bid, how the different sizes of the panels would actually interact with the module. Jenna talked about the 10-foot module. Some manufacturers, it hit right on and you might have a 2% waste, but some manufacturers, it could be significant waste. And when you start to think about all of the different sizes of panels that were available at that time, and there's more now, you notice that there's a large difference. And one in particular probably stands out to you. The really skinny one on the end, or next to the end, is from Vaughan, and that was an interesting change to make when you're in construction documents. One of the things that we learned after making that selection is that we couldn't actually penetrate with any mechanical, electrical, or piping within 4 inches of either side of the joint. So all of the white areas on the bottom diagram are places where we can't have pipes penetrate. So that was interesting to think about. You also notice there's a significant quantity more of panels, and you're wondering, like, did we make a mistake in terms of thinking about just the cost of the panels versus the erection? But actually, the real metric in terms of erection is really how many picks that you need to do. How many times do you need to take the crane and lift it onto the building itself? And this diagram was created by the trade partner to be able to show, and each different color is showing a different pick. So here you can kind of see the image of the crane, and what they're doing is, because those panels are less wide, they can actually stack multiple panels, do a single pick, lift up to 4 or 5 panels, and then just shake them. Ultimately, we were able to get to doing a floor in less than a week, which is a pretty fast for an overall like 12,500 square foot floor plate. But perhaps the biggest sustainability metric that struck me is how long would it take American forests to regrow all of the wood in the project? I'm talking about the glulam's, the CLT, all of it would be grown in 3 minutes. And this is forests that are actually in production. We also did take a look at embodied carbon. I know we talked about earlier that that's not something we talked about essentially in Eastern Oregon, but we wanted to understand what were the metrics around embodied carbon. And so as we were doing our structural analysis, and we looked first at the 13-foot-4 column spaces that needed a 5-ply, and then going to the 10-foot column spacing and a 3-ply, that was a 25% reduction in wood fiber, which is a good reduction in overall embodied carbon, reduces the amount of weight of the building, which also then reduces the concrete in the foundations. After the fact, we asked ourselves the question, what if we hadn't done concrete slabs? You know, David talked about the need for them both from a jurisdictional perspective as well as being able to embed all of the electrical and the conduit. But if we had chosen a raised floor system, we realized that there would be even more reduction in wood fiber and even more reduction in concrete. So this was done after the fact. And then the last piece that I'll talk about is really, where did the overall timber come from, and thinking about it not just from that 500-mile perspective, but also thinking about where are the logs actually being harvested? Are they being harvested in a way that restores timber, as Vaughan is doing? Are they being harvested on tribal lands, and so they're contributing to social equity? So we worked with Sustainable Northwest to create an understanding of how much of our timber came from these different sources, and you can see like 50% from the Yakima forests, and it's one great metric that we talk about.
So as most of you experienced in this last few years, ourselves, we as a team had to go through some challenges within the building construction sequencing. The big nasty ball there in the front end of our scope is COVID. So we broke ground in essentially the worst possible time. And the one benefit is we had a whole lot of laydown space. So you didn't have to be right next to anybody when you're doing your work as a trade partner for quite a while. So that did help. There were some challenges with the fact that a lot of the trade partners were traveling to Bend from larger regions, so that the general contractor had struggles with controlling some of the spread of COVID when they were off-site. So that was just a cultural thing we had to battle with. We had a bit of a wildfire season not too long after that, where we experienced a lot of smoke, and we actually lost some of our product that we were looking like we were going to source. Compounding that was the fact that one of our presses broke down in the selected manufacturer. So it was a wonderful story that you had these what could be competing market players actually working with each other, with our trade partners, to bring product to another manufacturer to have them pressed, because the first one's press had broken, to get the product delivered to the project on time. We had a change with the interface of the city of Bend. They changed platforms with which you submitted drawings with in the middle of this project. So there were lots of fun little challenges. And in the end, I think we were missing our hoped for completion date by about 5 or 6 weeks. So given all those challenges, we still think that was a pretty successful navigation through that process.
Well, we'd be happy to answer people's questions. I don't know if we have any in the chat, but we could.
I haven't seen any show up in the chat yet. AIA folks, please chime in how you'd like to do this, but as far as we're concerned, we'll take them verbally and turn on your cameras and ask us, or feel free to drop them in the chat. I'll keep an eye on that.
See the folks a little better.
No questions. Maybe too much.
Well, David, maybe what people are thinking about the questions, you know, it'd be, you told the story about the press, but there's a few little details about that story. So for those of you who know where Vaughan Timbers is. It's Colville, Washington, which is about 50, maybe 35 miles from Spokane. And Katerra, of course, used to have a plant in Spokane before they shut down and were bought by somebody else. When that press broke, we were able to, through working together with Swinnerton Builders and other folks, essentially be able to talk to Katerra about taking the lamb stock that was essentially from Vaughan Timbers, trucking it to Katerra's plant. They incorporated it at the bottom of the layer, so all of our CLT would visually look the same. They pressed the panels for the 2 or 3 weeks that our technician was off, getting essentially quarantined because the technician who had to essentially fix the press came from Europe. And at that time, everybody was quarantined if you were coming from over in the country. So it was about a 3-week process to get the person into the country to be able to even press it, and right at a critical time. But through the ability to work, and our structural engineer also played a really important role in telling us which panels really needed to have the extra E strength that was coming from the Vaughan panel, and which of the panels, the interior ones, really didn't. So that was a big help.
There's a lot more detail.
Folks out there in the audience. Yeah.
Yeah, it's unusual not to have any questions. So if anyone has a question, please feel free to put it in the chat box. And if there are not any questions, I think we can just thank the presenters. It was a fantastic presentation. We really appreciate it, and let everyone out a little early today. Okay, you guys have the record for hitting it all with perfectly.
Colleen, I was just thinking I should make people ask questions or they don't get the HSW.
It's a good plan.
Oh, there is something in the chat now.
Thanks, Brian.
How far the columns are from the wall?
Yeah, so we have about 2 inches of clear area from the back side of the finished sheetrock to the back side of the column. It paid dividends because we were not comfortable cutting through that column. The piping, there's actually 4 pipes, part of the gradient system, that we had to fit into that space. So we didn't want to go into the cavity of the wall because we had insulation in there as well. So it really was interesting to see how that worked, because during the late evenings in the sun, you really get the sunlight actually coming behind the column, between it and the wall, and it just really focuses on that move, which is, I just really like that a lot. That's it.
I think so.
Thanks, Brian.
Brian gets his
Brian gets his credit.
Yeah.
Well, thank you all for attending.
Do you want to mention that the building's actually open? So if anyone's
Oh,
hadn't
yeah.
been, can go
Yeah,
in
yeah.
there.
Yeah, good point.
For a long time, they had a policy of where you'd have to have a student ID or a badge, but they now are open at least, normal business hours. I'm not sure about the weekend, but normal business hours, you can walk in and see it. So if you find yourself over there, definitely take a look. And
Let's go.
And OSU-Cascades is doing a lot to build their own presence in the community. Most recently, they've started hosting the science pubs in Bend, which have been a downtown venue for years. If you've never been to science pubs, OMSI or elsewhere, it's basically scientists talking about cool stuff, and the pub part is that you can have a beer while you're listening. All of those are now happening in that beautiful staircase space, which just brings a lot of people to campus that might not otherwise have a reason to come, and a lot of energy to the space.
It's so good. Thank you for that.
Yep.
All right.
Great.
all right, thank you.
Thanks all.
Thank you so much. Have a good night.
Bye.
Too.
Good night, everyone.